So now our video, sorry I've not been available for about almost 2 weeks now. It's because I have a lot in hand to do, but let's leave that aside. How do you know when to use integration by use substitution? You check when the difference between powers or the powers of each different unit is one. The difference between the power of x to the power of 1 and the power of a to the x to the power of 5. The difference is 1. If you notice, the difference between x to the power of 2 or x squared rather normal 10x, the difference is 1. Take note of it here too. The difference is 1. So now you might be wondering, why did I include these two here? It's because you can also apply integration by parts to the case you come across questions like this. So I will be explaining how you solve questions like this for you guys. But for now, let's quickly touch this. So we have 10x to the power of x squared plus 6, close bracket, dx. Sorry. Now, sorry, this is to the power of 4. My bad. To the power of 4. Alright. So how do you solve a question like this? Let's make u be equal to what? Square plus 6. Now, if your u is equal to x squared plus 6, what do? You differentiate. That is, the u dx is equal to what? 2x. If your du dx is equal to 2x, then our dx is equal to what? Du over what? 2x. By cross multiplying, you bring this here and you take this here. Alright, so we can now rewrite by saying integration of 10x times, this is u to the power of what? 4. Then our dx is equal to what? Du over 2x. Du over 2x. So this can easily cancel out this. 2 here 1, 2 here 5. So we are now integrating what? 5 u to the power of 4 du. So once you are done with this, then what do you do next? You can either take the constant out or you do it directly. So either way it will work. So if I to integrate this, this will be 5 u to the power of 4 plus 1 over 4 plus 1. Then we add our plus c. So this will be what? 5 u to the power of 5 over 5. Your 5 will cancel out each other plus c. Now we can't leave our answer to be like this because our u initially is equal to what? X squared. Therefore, we can now say that our x squared plus 6 to the power of 5 plus c. This is our final answer for question 1. It's as simple as that. If you do not understand any part, you can reverse the video back or backward it and watch it over again and follow the steps. So that's all that I'll be doing here. Now, for question 2, we are told to integrate what? X to the power of 4, e to the power of x to the power of 5 dx. Now, what are we going to make? What are we making? What value are we going to make use of to be equal to u? So if you notice, I do aim for the one with the highest power. I aim for the one with the highest power here and make it u. So yeah, what do you think I'm going to make to be the highest power? Alright, so now let u be equal to what? X to the power of 5. So therefore our du is equal to what? 5x to the power of what? 4 dx. So if we divide both sides, you can say our dx is equal to what? Du over 5x to the power of 4. Can you see that? So we can now rewrite this by saying integration of what? X to the power of 4, e to the power of what? U, because that is what we make to be equal to u. That's what we equate to u. It will be e to the power of u. Then we have our dx is equal to what? Du over what? 5x to the power of 4. Now, from what I've been doing so far, I'm sure you must have noticed the trend, guys. we have been solving it in a way whereby our x is being getting rid of. So the same thing is what happened here. We got rid of the x and made it a constant. So the same thing is what will be happening here. X to the power 4 cancels to the power 4. So this becomes what? 1 over 5. I can easily take that to the back by saying 1 over 5 integration of e to the power of u du. And we all know that if, based on our previous video, we all know that if we are to integrate e to the power of u, it will still give us e to the power of u. Therefore, we can now see that this is 1 over 5 times e to the power of u. Then we can rewrite this back to the initial form and say by saying e to the power of what? X to the power of 5 over 5 plus c. But if you don't want to write it this way, you can just say 1 over 5 e to the power of x to the power of 5 plus c. So this is our answer for question 1 and 2. Now let's move to question 3. How are we going to solve it? We are going to be applying, we will be applying the same format in which we use for it. So let's rewrite. We have x to the power of 3 over what? 8 plus x to the power of 4 to the power of what? 3 dx. Now, without me saying anything, you know what to do here. Our u will be equals to what? The one with the highest power, that is, u is equals to 8 plus what? X to the power of 4. Then we can now say, by now, you already know what I have been doing so far here. So let me just move by saying our dx is equals to what? If you find the derivative of this, it will give us what? Our du over what? 4x to the power of 3. If you do not understand how I got to this point, reverse the video and watch how I did question 1 and question 2. Then you understand how I got this. So now we can now rewrite by saying integration of what? X to the power of 3 over, this is u to the power of what? 3. Then our dx is equals to what? Du over what? 4x to the power of 3. Can you see a pattern? This will cancel this, this will cancel this. So we are left with just 4. We can easily bring out the 4 and say 4 integral 1 over what? U to the power of 3 du. Now let's integrate this normally. So we have our 1 over 4. Let's open a bracket for it. This will be what? U to the power of what? Minus 3. Then we add plus 1 over minus 3 plus 1. Close bracket. We have our plus c. So we can now write this by saying 1 over 4, or let's open a bracket for it, e to the power of minus 2, then we have our minus 2 here, close bracket plus c. So we can still also rewrite it by saying 1 over 4, then we can take this minus 2, because the coefficient here is 1, so we can take it as what? Times minus 1 over 2 times, then this our u to the power of 2 is same thing as saying what? 1 over what? U square. Then let's add our plus. So let's put all this in brackets to avoid confusion. Alright. So we can now write this by saying minus 1. We have 4 times 2. And that will give us what? 8. Then our u initially is equal to what? Let's open the bracket for it. 8 plus x to the power of 4. Then the power here is what? Square. Then we can add our plus c. Then we can add our plus c. Then you can say this is our final answer. So we are done with what? Question 3. Like I said, I won't be taking much of your time today. Now, how do we solve a question whereby question 4? Oh, sorry. Now, how do you solve a question whereby your powers are what? Are on the same level? and at the same time you can't multiply. So whenever you come across a question like this, it becomes very difficult to solve. So this is what you will do. Your U substitution will still be applicable to this, but the way you do it is that do you know now which one are you going to be using for U? The question is, because this is in what? Under the roof of root. You know we can easily rewrite it as what? So because of this reason, then I'll be making 4 minus 5. Because of this reason, I'll be making my 4 minus 5 to be equal to what? My U. So therefore, you can now say our U is equal to what? 4x minus 5. Now, if you should differentiate this, that is to give you the U is equal to what? Just ordinary for the x. Then you can say that the x is equal to what? The U over 4. Now, 4 will only cancel 2. We'll still be left with x. Then what do you think is the solution? Some people might get stuck in and assume there's nothing else to do, but there's something else you can do to it. Remember, our U is equal to what? 4x minus 5. Let us make x the subject of the formula here. So if x is the subject of, let me rewrite this first. So if you have to make x the subject of our formula, that will be what? U minus 5 is equal to what? 4x. You divide both sides by 4. And our x is equal to what? U minus 5 over what? 4. Now, we can now safely rewrite this as what? 2 in brackets, the whole of this, in order for it to what? Fit in. So this is what we do. We can rewrite our integration formula as what? This is 2 in bracket U minus 5 close bracket 4 times, or you can choose not to write times, our square root of what? U. Then this will be our du over what? Dx is equal to du over what? 4. So we can get rid of all these constants and take it outside in order to avoid confusion. So what do I mean by that? Okay, let's cancel this. 2 here 1, 2 here 2. So you can just take 2 times 4, that's what? 8. Let's take out 1 over 8 outside. Then we are left with what? U minus 5 in bracket square root of U du. So now we can now safely integrate. But before we integrate, let us expand. By doing that, you have 1 over 5. This will give us what? U root U minus 5 root U. Then we have our u. So we can now integrate separately by doing it that way. Now, before we integrate separately, we can also rewrite this. This is the same thing as what? U times what? U to the power of half. Following the law of indices. That will give us what? U to the power of, the power here is 1. So that will give us 1 plus what? 1 over 2. And that will give us U to the power of what? 3 over 2. So if this is going to give us 2 to the 3 over, so you can now rewrite the whole of this as what? 1 over 5 integral U to the power of 3 over 2 minus 5. We can write this as what? U to the power of half du. Then it is easier for us to integrate now without any obstacles. Alright, how do we integrate? 1 over 5. Let's open a bracket for it. This is U to the power of what? 3 over 2 plus 1. 3 over 2 plus 1 minus 5u 1 over 2 plus 1. 1 over 2 plus 1. Close bracket plus our c outside. Now what's next? 1 over 5 in bracket 3 over 2 plus 1 will give us what? Using our LCM, that will give us 5 over 2. So we can write this as saying u to the power of 5 over 2 over what? 5 over 2 minus 5 u to the power of half plus 1 is 3 over 2. Then this also gives us 3 over 2. Close brackets, can still put our c outside. Or you can choose not to put your c until you get to your final answer and the choice is yours. Alright, so for us to revert this, then 2 will be coming up, 5 will remain down. So this is 1 over 5. Let's open bracket. This becomes 5 u to the power of 5 over 2 Sorry, my bad. 2 is coming up. 2u to the power of 5. 5 is down. Minus, the same thing goes for this one. So it will be 2 times 5. That will give us 10. Or let me further break it down. So it will be 2 times 5u to the power of 3 over 2. Over what? 3. Close bracket. You can choose to add your c for now. So now, let's now finalize this by saying 1 over 5. Let's open bracket. Our u is what? 4x minus 5. So you can say 2 in bracket 4x minus 5. Close bracket 5 over 2 over 5 minus 2 times 5. That's what? 10. Then our u is what? Open bracket 4x minus 5. Close brackets to the power of 3 over 2. Everything over 3. Then you now add plus what? C. Then you can call this our final answer. With the exception, maybe if you want to expand, if you choose to expand, then the choice is yours. So we can leave our answer like this. Don't forget to always add your constant because we are still under indefinite integral. So this is the solution to the answer for this. Now as for this, you all know my style. I don't solve all the questions for you. So this is my assignment for you guys. You guys should solve it and give me your answer in the comment section. So this is where I'll be stopping for today. All right. Before I show any form of application, have a clear view and you can have a screenshot of this. So this is everything that we did today. So you might want to take it down 1 or 2 notes. All right. I'm sure by now you must have done that. All right. Thank you very much for watching our video. Kindly like and subscribe and turn on the notification bell. Share it with your friends and help them out so they can learn integration by substitution in the easiest way possible. Thank you very much. See you in our next class. Thank you.